Okay, we have a few points in 3D here, and we've been asked to connect these points or find the vector that's equivalent to the line that connects these points in terms of direction and magnitude. So the way we do that is fairly straightforward. To find the vector PQ, we just take the components of Q and subtract the components, or the components from P. So that vector is going to be minus 5, 1. So there's our vector. You can think of that as starting at the origin and going to the point minus 5, 1. Or you can think of it as starting at the point 6, 4, minus 2 and going to the point Q. Right? Either way you think of it, those are equivalent vectors, and either way is okay. So that's the answer to A. B asked us to find a unit vector in the same direction as PQ. So we want a unit vector with the same direction. So to find a unit vector, given this vector, what we need to do is find the length of PQ, or the magnitude of PQ. So the magnitude of PQ is the square root of the first component squared plus second component squared plus the third component squared. So this is 25 plus 25 plus 1. This is the square root of 51. It's not a perfect square. We just leave it like that. I think that's 17 times 3, so we can't really modify the square root at all. So that's the length of PQ. So if we take our current PQ, which is minus 5, 1, and if we divide by its length, divide by that square root of 51, then we have the unit vector. That's what the hat notation is that this is a unit vector. So what have we done? We haven't changed the direction of this vector at all. It's still minus 5, 1. We're multiplying by a scalar, 1 over the square root of 51. And remember that multiplication by a scalar just scales the vector. It just changes the length, but not the direction of the vector. So we've changed the direction, we've changed the length of this vector, and now if we were to check the length of it, we would have length 1. So we don't change the direction, this has the same direction, but we've scaled it down to have length 1. So this is a unit vector in the same direction. The hat notation denotes unit vector. So there's a unit vector in the same direction. The third part said find a vector pointing in the opposite direction with length 3. So a vector pointing in the opposite direction with length 3. Well, to make it the opposite direction, we'll multiply by a negative 1. And to make it length 3, we'll multiply by 3. So take this same unit vector that we had, minus 5, 1 over the square root of 51. That part has length 1. So if we multiply by a negative 3, we'll get something with length negative 3. And so now we have a vector with length negative 3. With length 3. You don't have length negative 3, but a vector with length 3, and the negative means it's pointing in the opposite direction. So this accomplishes what we were asked to do. Those are the types of things that you'll be asked to do in the homework with vectors.